Okay, so now we're trying to deal with the backpropagation problem right here. So this is our function. This is phi2, w2, phi1, w1, and x. And then we have our error function. It's psi. Psi with the function minus the the actual label or whatever. This is not important. This is how it's defined, and so this function that actually is this one right here is a measure of MSE basically. So what we need to do is, first of all, we derivate according to u1 right here. Instead of w1, we just do u1. So we can use simply the method we used before in the lecture to derivate according to x, which the only difference is we don't have the Jacobian of w1 right here. So the Jacobian with respect to u1 is going to be like this, and but we want to do the gradient, which is the transpose of Jacobian, which will be like this. Yeah, of course we also because of this formula right here, we need to add this. We also need to add the last derivative according to the error function gradient. So now we need to figure out the differentiate of E. So according to the definition, the differentiate equals to the gradient times the differentiate of the variable itself, which is u1 right here. And then we can separate the u1 into the differentiate of w transpose multiplied by x. So because this is a scalar form, because it's it's an error, so we'll do a trace of this, so it will be the same. And then because it's a trace, we can use the property of the trace. We can move the x into the front, so the circulation, something like that. Therefore we can separate, we can make it like this form. So we can separate them because the trace, so we can separate them into an inner product of this term and this term. Therefore we will know that this is the gradient, because this is the differentiate of w1, and this will be the gradient. That's how the definition is of a gradient. So so we just expand it, and be x. It's gonna be this result right here, and we also need to explicitly written what is the gradient of phi with respect to r. So because phi we know is MSE, like 1/2 times the MSE, so the gradient will be just whatever v is, and the v in our case is this. So that's it.